Have you ever just felt totally overwhelmed by, the sheer complexity of the universe?
Oh, absolutely.
I mean, you've got gravity, electromagnetism, the weak and strong nuclear forces, then there's dark energy, dark matter. It's just this huge stack of different
Oh,
concepts.
it really is. It feels like a patchwork sometimes.
Exactly. But despite all that, this incredible information overload, there's still that core human desire, isn't there? For a theory of everything.
Mm-hmm. That single, elegant key.
Yeah, a master key that just explains how everything holds together, how order and stability are, maintained.
It's a powerful drive.
Well, today we are diving deep into source material that attempts to provide exactly that master key.
Okay.
Our sources lay out this really comprehensive theoretical framework. It's focused squarely on the foundations of hyperspace physics.
Right, so we're going beyond the usual dimensions here.
Oh, yeah. And this isn't just like abstract theory building for its own sake. It's a genuine attempt to unify our understanding of all physical forces. Everything from the tiniest molecular bond.
All the way up to the biggest things we see, like cosmic filaments.
Exactly. It's a huge scope.
It is. And our mission today, really, is to unpack this proposed unified model.
Okay.
It describes how order and integrity, how things hold together across all these scales. And it does it by linking three core principles:
Which are?
coherence, cohesion, and resonance. The idea is to tie these into a single generalized mathematical framework.
A single framework. Wow.
And like you said, we're moving far beyond our familiar four-dimensional space-time. The sources talk about a hypersymmetric reality.
It really does sound like an architectural deep dive into reality itself.
That's a good way to put it.
We're going to explore what they call the ultimate binding force, tracking it from, say, the stability of a single proton all the way up to the structure of the entire omniverse.
Which means we'll have to rethink some really fundamental concepts.
Like mass and gravity, right?
Exactly. Mass, gravity, even the nature of physical constants.
So for you listening, you're about to get a shortcut, maybe, to understanding a pretty revolutionary perspective on physics. Okay, let's unpack this, right? So let's start with those foundations, that triad you mentioned: coherence, cohesion, and resonance.
Mm-hmm.
Now, in everyday language, those words kind of blur together, don't they?
They do. They overlap quite a bit.
But this framework seems to give them very precise, interconnected roles.
Mm-hmm.
So let's start by trying to differentiate coherence and cohesion. What are the operational definitions they're using here?
Okay. So coherence and cohesion, they describe two distinct aspects of how stable a system is. Cohesion is probably the easiest to grasp first.
Okay.
It's just the general property of being held together.
Yep.
Maintaining the physical integrity of a system. Could be a block of steel, could be a planet. It's the glue.
Piglet, got it. Simple enough. And coherence, that sounds a bit more abstract.
It is a bit more refined, yeah. Coherence refers to the logical consistency, the order, the unity within the system. In standard physics, we often use it when talking about waves, right? Like the phase alignment of waves. Think of a laser beam. All the photons are perfectly in sync, perfectly phase aligned. That's high coherence.
Right.
So in this framework, coherence represents the degree of structural alignment, but also informational alignment across a system. It's more like the blueprint for stability, not just the glue.
Okay. So cohesion is that a system holds together, and coherence is about how well ordered the parts are to make that happen.
Precisely. You nailed it. And here's where the sources make their first really big conceptual leap.
Okay.
It involves something called hypergravity.
Which we'll get into more later, I assume.
Definitely. But for now, the key thing is that hypergravity is proposed as this fundamental, pervasive, inescapable fabric of the entire omniverse.
Right.
And because of this pervasive hypergravity, coherence isn't just a local property. It's treated as a universal, non-local thing.
Universal. How so?
Because hypergravity ensures that structured, consistent information, the blueprint flows seamlessly across all dimensions of hyperspace.
Wow. Okay.
So coherence isn't just some random accident that happens here or there. It's presented as a fundamental law of physics, dictated by the underlying, unchanging structure of reality itself.
That immediately gives coherence a much bigger role than just, like, wave alignment.
Exactly. It's not just a measure of alignment. The sources argue it's a guaranteed consequence of the basic architecture of existence.
Okay, that's a huge idea. And it leads us right into the next core point, under 1.2 in our outline. Resonance as the universal principle. If coherence sets the stage, the ordered structure, how does resonance actually create the cohesion? How does it make things stick?
Right. So the framework argues that resonance is the dynamic, the active mechanism behind it all.
The engine?
Kind of, yeah. The core thesis is pretty straightforward. Resonance is the mechanism that binds elements together. It maintains the system's integrity through continuous, dynamic, resonant interactions.
So things are stable because their parts are constantly sort of humming together.
Yeah,
Finding resonant alignment.
that's a great way to put it. They're finding resonant alignment with the forces and fields all around them. It's an ongoing process.
Okay. And here's the part that really jumped out at me from the sources. They propose that resonance is functionally identical to cohesion. They basically collapse the two concepts.
Yes, that's a critical point. They treat them as essentially the same phenomenon, just viewed from different levels of analysis.
How does that work?
While cohesion is the observed macro effect, you see the system is held together. Like the planet stays intact.
Right, the outcome.
The outcome. Resonance is the dynamic microcause. The underlying elements are oscillating in harmony, interacting in specific ways.
The process.
The process, exactly. So by declaring them functional identical, the framework is really emphasizing that resonance is the universal fundamental characteristic of hyperspace that's responsible for all forms of binding energy.
Whoa. Okay, so if we look at any force we normally call cohesive, I don't know, like the strong nuclear force holding an atomic nucleus together,
Yep.
or even something like the van der Waals force that makes water molecules clump up.
Mm-hmm.
You're saying this framework argues that at the deepest level, those are all fundamentally resonant interactions.
That is the precise implication, yes. Resonance isn't just one type of binding among many. It is the single foundational force behind all cohesive behaviors. And it operates seamlessly from the tiniest quantum scales all the way up to the largest cosmic structures.
That really simplifies the picture, doesn't it? Instead of juggling all these different forces, you're viewing all forms of connection as just different expressions of the same basic principle,
No.
harmonic alignment.
Aims for that kind of simplification, yes.
Yeah.
A unification based on process and dynamic state, rather than, say, finding a single force-carrying particle for everything.
Understanding that functional identity, then, seems crucial for the next step, 1.3, which is the grand goal.
Yeah.
Building a comprehensive theory of everything. How does unifying these three concepts, coherence, cohesion, resonance, actually help achieve that huge objective?
Well, the objective is to get away from dealing with all these apparently disparate forces as separate things. Instead, the goal is to unify hyperdimensional coherence metrics, how ordered things are in higher dimensions and resonant conditions, into a single, unified model.
A model that describes information and structure across all scales.
Yes, all scales. By integrating these principles, the framework is essentially proposing a deeper, more holistic symmetry underlying reality.
Like finding symmetries in particle physics.
Kind of analogous, yeah. The idea in physics is often that if you find the correct underlying symmetry, then the forces and particles we observe just naturally emerge from that symmetry.
Okay.
So here, the proposed underlying symmetry is this universal resonance, which is modulated or shaped by coherence, all happening within this stable background of hypergravity. If that's the true symmetry, then all the forces we see, gravitational, electromagnetic, nuclear, should naturally manifest as observable phenomena at different scales or energy levels.
So it's unification through understanding the process and the dynamic state, not just finding common building blocks.
Precisely. It's elegant.
It sounds incredibly elegant.
Yeah.
But, elegance in physics only gets you so far if the math doesn't back it up.
Absolutely. The proof is in the equations.
Okay, so let's move from these conceptual definitions into the hard numbers. How does this translate into mathematics?
Right. So if we accept the premise that all cohesion is fundamentally resonance, the big question is how the sources turn that elegance into actual predictive mathematics. How do we even start building that kind of unified equation?
Okay, the first step is you have to mathematically define the underlying state of the system, what's actually oscillating.
Right.
So under section 2.1, we introduce the starting functions. The core is the universal resonance function, usually denoted as 1x.
R for resonance makes sense.
Yep. And it's essentially a generalized wave equation, it looks like. 1x r megan t plus phi naught. Okay, whoa. That looks a bit intimidating. Can you break that down for us? What is that R function actually telling us in plain English?
Sure. It looks complex, but the parts are familiar. It tells us the total resonant condition, the overall vibe, if you like, at any specific point in space, that's the 6all, and any specific moment in time, that's the 2.
Okay.
The summation symbol just means it's adding up potentially many different overlapping resonant patterns or waves.
Yeah.
That's the index of $1.
Right, because things aren't usually vibrating in just one simple way.
Exactly. Then $1 is the amplitude of each wave, basically how strong or intense that particular resonance is. Omega is the angular frequency, how rapidly it's oscillating. And omega in Ophi is the phase that's about the timing or alignment of that specific oscillation relative to others.
Got it. Amplitude, frequency, phase, standard wave stuff.
Standard wave stuff, but applied universally. So this function, Poneja, defines the fundamental energy signature and stability potential of that point in spacetime. It's the base layer.
And the cohesion function, C, you mentioned earlier, that then depends on this R state.
Exactly. The next step is defining no xxt x whole f rxt.
So cohesion is some function, $5 of the resonance function.
Yes, and this is absolutely vital. It mathematically establishes resonance, $3, as the dynamic underlying condition that governs all cohesive properties.
Meaning if the resonance changes.
If the resonance state $3 changes, then the cohesion $1 must change accordingly. The specific mathematical form of that function, $5, is what differentiates the various forces.
Ah, so the $5 is different for gravity than it is for, say, the strong nuclear force.
Precisely. The function dollars captures the specifics of the interaction at a given scale or context. But crucially, they all share the same foundation in the underlying resonance field, $3.
Okay, that makes sense. It provides the link. Now, here's where, for me, it gets really interesting. Section 2.2 talks about modifying traditional existing cohesion equations using this resonance idea.
Right. This is where the rubber meets the road, theoretically speaking.
We're talking about taking familiar formulas from physics and chemistry textbooks and actually rewriting their parameters to show that they're secretly based on resonance.
That's the goal. We can start small with molecular interactions. Think about the van der Waals force.
Okay, yeah. That's important for how fluids and gases behave, right?
Yeah.
The sort of weak stickiness between molecules.
Exactly. The standard van der Waals equation has a parameter, usually written as a dal, which classically represents the average attraction between molecules.
Right. A measure of stickiness.
Well, in this new framework, a dollar isn't just a constant for a given molecule. It's reinterpreted as a dollar. It becomes a function of the local resonance state.
So the stickiness itself depends on resonance.
Yes. It means the parameter dal is now seen as a measure of the resonant interactions between the molecules.
What does that imply, practically? Does it mean the attraction between, say, water molecules could actually change depending on the temperature or local energy fields or something?
That's precisely the implication. If ALI is derived from the underlying resonant frequency or the phase coherence between those molecules, it suggests that the actual strength of their mutual attraction isn't a fixed quantity. It's a dynamic measure of how well aligned they are, resonantly speaking.
Huh. So imagine trying to get something to stick together. The cohesive force would be strongest only when the components are vibrating or resonating in harmony.
That's the picture, yeah.
Yep.
Maximum cohesion requires maximum resonant alignment.
That's a really fascinating reinterpretation. Okay, let's scale up slightly. What about the Leonard-Jones potential? That describes the energy of bonds in solids, right?
Yes, it models the potential energy between two neutral atoms or molecules. It's fundamental to understanding solids and liquids.
And it has key parameters, too.
It does. Two main ones.
Epsilon?
Epsilon, which is the depth of the potential. Well, basically, it defines the maximum bond strength, how much energy it takes to pull the atoms apart.
Okay.
And sigma, which is the distance where the potential energy is 0, it relates to the equilibrium distance between the atoms.
Right, bond strength and bond length, essentially.
In essence, yes. And in this resonant framework, guess what happens?
They become functions of R.
You got it. Both epsilon and sigma bell become functions of the resonance state. Epsilon and sigma.
Okay, and this isn't just like theoretical decoration. It has real consequences.
It absolutely implies real consequences. It means the energy needed to break a bond in a solid and the optimal distance between its atoms aren't fixed constants for that material. They could actually fluctuate dynamically depending on the system's overall resonant state. True dollars.
So, the intrinsic strength of a material, say a piece of metal, might not be absolutely fixed just by its atomic structure alone. It could be subtly influenced by the level of local coherence, the resonant environment it's in.
That's the implication. It potentially connects materials science directly to the wider hyperspace environment. It suggests that if you could somehow precisely manipulate the local resonance function, $2,
You could potentially tune the bond energy epsilon of material, make it stronger or weaker.
theoretically, yes. Or change its equilibrium structure slightly. It opens up some pretty wild possibilities down the line.
Wild is right.
Okay.
Now for the really big one, the most radical shift mentioned here, gravity.
Ah, yes, gravity.
You mentioned earlier that even the gravitational constant, the famous big G, gets redefined as the jet.
Yeah, that's correct. DD dollars becomes DR.
So the fundamental force holding planets in orbit, holding galaxies together, that force itself is dynamically varying based on this universal resonance. The equation becomes phi dollars, GR, NENT, fracum 1 millidor
Yes. This is probably the most fundamental disruption to classical and even relativistic physics proposed by this framework. It takes d/dollars dollars from being a fundamental constant of nature.
Something unchanging, universal.
Right, and turns it into an emergent property, a value that is determined locally, dynamically, based on the resonance conditions.
Do the sources give any indication of how G arises from resonance? Is there a deeper equation for G?
They do. They propose a derivation. The idea is that g dollars is derived from the inherent properties of that invariant hypergravity field. Let's call its property all in the distance. And dollars not, or the resonance function this time, confusingly. Assuming perfect coherence, g dollars equals HR2.
Wait, G dollars HR TDR2. That looks like the inverse square law itself.
It does, doesn't it? The dollar here represents some fundamental potential or property of the hypergravity field. The $2 reflects the geometry. But the value we measure as g dollars depends on how efficiently mass interacts with this hypergravity field, which in turn depends on the local resonance and coherence. So implicitly it becomes GRX, even if the base derivation looks geometric. If the measured dollar were to change, it would imply that the local resonance dollar is shifting.
Okay, hold on. If G isn't constant, I mean, we've been measuring gravity incredibly precisely for centuries. Why haven't we seen G changing here on Earth or in the solar system?
That is the absolutely crucial question, and the sources address it through the concept of scale and coherence domains. The suggestion is that within a relatively small, highly coherent emergence event like our solar system, or perhaps even our local galactic neighborhood, the fluctuations in the resonance function might be extremely small or vary over incredibly long cosmological timescales.
So, for all practical purposes within our local bubble, G looks constant.
Exactly. It appears constant because our local environment is assumed to be in a highly stable, coherent, resonant state. The difference, the dynamic nature of dollars, would only become truly apparent when you compare measurements across vastly different cosmic regions.
Like comparing G in our galaxy versus a galaxy billions of light years away, which might exist in a completely different resonant environment.
Precisely. The framework suggests the true dynamic nature of GR is revealed only when you look across these vast, potentially multiversal scales where the underlying $2 function could be significantly different.
Okay, so that puts the constant and gravitational constant in huge cosmic scare quotes.
You could say that, yes. It's locally constant enough for us, but perhaps not universally invariant.
So if gravity, molecular forces, chemical bonds, if they're all unified under this umbrella of resonance, what's the actual master equation, the single formula that captures all of them?
Okay, that brings us to section 2.3, the proposed universal equation for cohesion. This is the equation that aims to mathematically describe the unified force field generated by resonance.
The big one.
The big one. It's written as 5 cohesion, XTAT, nabla RX.
Okay. Definitely the most complex expression so far. We absolutely need to break down every single piece of that for the listener. What's the overall story this equation is telling?
The overall story is that the cohesive force is generated by the, let's say, the flow and the resistance of the resonance field itself.
Flow and resistance. Okay, let's look at the parts. You've got RXT in there twice.
Yes. Let's start inside the parentheses. You have nabla RXT. That's the gradient of the resonance function.
Gradient, like the slope on a map. It tells you the direction of steepest descent.
Exactly like that. The gradient vector, nabla R, points in the direction where the resonance function brawlers is increasing most rapidly, and its magnitude tells you how steep that increases.
So physically, what does the gradient of resonance mean?
Physically, it represents the drive or pull towards higher resonance. The sources suggest that systems will naturally feel a force pushing them towards states or locations of maximum resonant harmony or alignment. The gradient nabla R points the way.
Okay, so the force is fundamentally driven by the system's tendency to become more resonant. like things wanting to fall into harmony.
That's the core idea. Then outside the parentheses, you have the Nabla operator. That's the divergence.
Divergence. That measures how much a field is spreading out from a point, right?
Precisely. It measures the outflow or inflow of the field. In this context, the divergence of the term inside tells you the extent to which the lines of this resonance-driven force are expanding out from positive divergence or collapsing into negative divergence, a specific point.
So positive divergence means cohesion is sort of emerging or flowing outwards from that point.
That's the interpretation. And negative divergence would mean it's collapsing or concentrating there.
Okay, gradient drives it towards harmony. Divergence describes the source sink behavior. What about the crucial middle part, the K, KRX, K?
That's the resonance stiffness parameter. This is the essential piece that connects the general resonance field, $3, to a specific observable force, $5.
Resonance stiffness. Okay.
Think of it like the stiffness of a spring. K of t is a function that represents the system's inherent resistance to changes in its resonance state.
How easily or difficult it is to push it out of its current resonant pattern.
Exactly. If TRR is very large, the system is stiff. It strongly resists changes in thalers. This, according to the framework, leads to strong, short-range, localized forces. Think nuclear bonds.
Okay. High stiffness, strong local force.
Conversely, if TR is small and perhaps spread out over large distances, the system is loose. It doesn't resist changes in the dollar very strongly. This would correspond to weaker, long-range, pervasive forces.
Like gravity.
Like gravity. So TR is the key modulator. It depends on the resonance state itself, and its specific mathematical form determines which force you're actually describing.
So this is incredible. It means the forces we experience, electromagnetism, gravity, the nuclear forces, they aren't fundamentally separate phenomena in this view.
Correct.
They are all just different manifestations of this single underlying resonant equation. They're distinguished only by how stiffly or loosely the specific system or scale resists changes in its resonance state, as defined by K.
That's the unifying power it aims for. You change the mathematical structure of the coefficients, how it depends on trailers, and you switch from modeling, say, a chemical bond to modeling the curvature of space-time due to gravity, all from the same foundational equation.
Mind blown. Okay, that's the mathematical core. But this whole thing is built on the idea of hyperspace. We set up the math, and it seems to unify forces within our familiar dimensions. But, as you said, the framework itself is built on the concept of hyperspace.
Yes, that's fundamental to the whole structure.
So Section 3 in our outline takes this unified math and generalizes it to that higher dimensional reality. How exactly does the theory incorporate extra dimensions?
Okay. This is covered in 3.1, generalizing to what the sources call hypersymmetry and dynamics. The basic step is to extend the resonance function itself.
From RP
to RHXTY. The H then stands for hyperspace, and the new variable represents those additional hyperspace dimensions beyond our usual 3 of space and 1 of time.
Okay, so the resonance field exists and varies in these extra dimensions too.
Exactly. And here's the crucial realization that comes with it. The forces we just modeled using the cohesion equation, gravity, molecular attraction, etc., are proposed to be merely lower dimensional projections of the true cohesive forces.
Projections, like shadows on a wall.
That's a perfect analogy. We, living in our 4D spacetime, are only observing the shadow or the residue of the more fundamental, higher dimensional cohesive forces that are actually operating in the full hyperspace.
So the forces we feel and measure are just incomplete versions of a deeper reality.
That's the perspective. And this framework then links this idea of hypersymmetric coherence, orderliness in these higher dimensions, directly to the concept of negentropy.
Negentropy, that's like negative entropy, right? A measure of order and complexity.
Exactly. Sometimes called syntropy. It's the opposite of entropy, which measures disorder and randomness. The framework states quite clearly that systems possessing higher hypersymmetric coherence naturally exhibit greater negentropy.
Meaning they're more ordered, more complex, more stable.
Yes. The higher the coherence across all dimensions, including the hyperspace ones, the more negentropic the system is. In this view, coherence is essentially the active force driving organization and fighting against the universal tendency towards chaos or entropy.
Wow. Okay, if negentropy is actively driven by coherence, that implies the universe isn't just passively running down, decaying into heat death, like the standard thermodynamic picture suggests.
That's a major implication.
It suggests the universe, or maybe the omniverse, is constantly striving towards higher, more complex states of organization, actively sustained by this alignment in hyperspace.
That is very much the interpretation offered. The framework even suggests that negentropy is proportional to the squared magnitude of the hypersymmetric resonance function. This implies that stability and order aren't static things you just have, they are dynamically maintained by the resonance state.
Okay, that's a fundamentally different view of cosmic evolution. If the universe is actively maintaining order, what's the absolute bedrock? The foundation upon which all this dynamic coherence and resonance is built? That must bring us back to hypergravity.
Yes, section 3.2, hypergravity, the invariant fabric.
You mentioned earlier is the unchanging substrate. Can you expand on that?
Absolutely. Hypergravity, often denoted auto dollars, is positioned as the truly fundamental, absolutely invariant field or fabric of the entire omniverse. It's the base layer.
Invariant meaning.
Meaning it provides the constant, unchanging substrate for all mass and all interactions to occur within. The sources are very explicit. Hypergravity does not vary spatially or temporally. It's the same everywhere and always.
So it's not like space-time and general relativity, which can warp and curve.
Yeah.
Hypergravity is fixed.
Exactly. Think of it as the stable, infinite medium, the deepest structural layer of reality itself. Its absolute permanence is what lends underlying stability to everything else that happens on top of it, so to speak.
That clarity is really important because if hypergravity is the constant, unchanging background, then what is the engine of change? What creates the dynamic, evolving universe we actually observe?
Right. If the stage is fixed, what makes the play happen? The answer, according to section 3.3, is the coherence field, paper cabin.
Ah, back to coherence.
Yes. Since the hypergravity field, $L's is constant and invariant, all observable variation, all movement, all structure formation, all dynamics in the universe are driven solely by the dynamic changes in the local coherence field.
Okay, let me make sure I get this. The universe isn't changing because the fundamental background fabric itself is wiggling or expanding in some intrinsic way.
Correct.
It's changing because localized patterns of coherence are forming, shifting, and dissolving against the backdrop of that absolute stability provided by hypergravity.
You've got it precisely. It's the patterns on the canvas changing, not the canvas itself.
And the framework connects this directly to complexity and organization.
Yes. Increasing local coherence leads directly to greater organization and complexity in matter. Things become more ordered, more structured, more stable as their coherence increases.
And there was some speculation mentioned about life.
Yes, the framework speculates, and it is speculation at this point, that this increase in organization driven by coherence might enhance the grip or the cohesion between the inertial frame of our universe, our 4D spacetime, and the coherent dimensionality of mass itself.
Okay.
Enhance the grip. Meaning make mass more stable, more persistent, more able to form complex structures. And this enhanced coherence, this drive towards hyperorganization, is tentatively suggested as the necessary groundwork for the emergence of life.
Because life is like the ultimate in complex organized matter, a highly coherent resonant state.
That's the idea. Life as perhaps the pinnacle of localized coherence within the hypergravity field.
That's definitely high-level speculation. Is there any attempt in the sources to provide a mathematical link between this coherence field, the Acalcer, and, say, the complexity of biological structures? Or is it more philosophical right now?
It's presented more as groundwork, laying a potential foundation rather than a fully worked-out theory of abiogenesis. However, they do try to connect it mathematically through stability factors. For example, they introduce a hypersymmetric stability factor,
Gamma H, related to the Lorentz factor.
It looks similar. They show it decreases with velocity, like gamma H V1, V2C2, but multiplied by some function related to dimensionality, f-text dimensionality.
Okay.
The point is, they directly link relativistic effects, which are obviously critical for how energy and matter behave in complex systems, to a reduction in this dimensional coherence factor as velocity increases. So there's at least an attempt to tie coherence into established physics relevant to complex structures.
Interesting. Okay, let's talk about maybe the most tangible thing affected by all this. Mass. We usually think of mass as intrinsic stuff, the amount of matter in an object. But here it's defined very differently.
Very differently indeed. Mass is not considered inherent or fundamental in this model. It is acquired.
Acquired? By what?
It's acquired by what the sources call resonance points. You can think of these as fundamental nodes or points where energy and information converge in the hyperspace field.
Okay, these resonance points exist.
And they acquire mass through their dynamic interaction with the invariant hypergravity field, $.
So mass comes from interacting with the background field.
Yes. And crucially, the efficiency of this mass acquisition process is stated to be directly proportional to the local coherence.
Directly proportional. So where coherence is high.
In regions of high coherence, these resonance points can efficiently tap into the hypergravity field dollars and acquire stable, persistent mass.
And where coherence is low.
In low coherence regions, mass acquisition is weak, perhaps transient, or the resulting mass might be unstable. It doesn't stick as well.
So let me see if I understand this inversion correctly. It's not that having mass makes something stable.
Right.
It's that achieving a sufficient level of coherent resonance within the unchanging hypergravity field is what allows something to acquire stable mass in the first place.
You've absolutely got it. Stability, driven by coherence, dictates mass acquisition, not the other way around.
That's a profound reversal.
It is. And the sources go further, proposing that measuring the local coherence field, bar xt, should be mathematically equivalent to measuring the local distribution of effective mass energy. They become two sides of the same coin.
Okay, we've gone from the micro to the macro, unified forces, redefined mass. Now we shift to the truly grand scale. Section 4 looks at how this whole unified, hyperdimensional view transforms our understanding of the cosmos itself.
Right, the cosmological implication.
And it starts in 4.1 by challenging something really fundamental.
Mm.
The idea that the constants of nature are actually, well, constant and universal.
Yes, this takes aim at the bedrock constants, big G for gravity, alpha, the fine structure constant for electromagnetism, h-bar Planck's constant for quantum mechanics.
The numbers that define our physical reality.
Exactly. The standard view is that these are just fixed arbitrary numbers that were somehow set at the very beginning of the universe. This framework says, no, that's not right.
So what are they then?
They are proposed to be hyperharmonics.
Hyperharmonics, like musical harmonics, but on a cosmic hyperspace scale.
That's the analogy, yes. They aren't arbitrary numbers plugged into the equations. They are resonant frequencies, or stable modes, that emerge naturally from the mathematical structure of the underlying hypergravity and coherence, specifically within our local bubble or region of hypersymmetry.
So G, alpha, H bar, they are consequences or derivatives of the cohesive structure itself, not external rules imposed on it.
Exactly. They emerge from the system. They don't dictate to it from outside.
This sounds like it could offer a structural solution to that really nagging problem in cosmology, the fine-tuning problem.
Ah, yes, the anthropic principle territory.
Right, the observation that if these constants were even infinitesimally different, if G were a tiny bit weaker, or the electron charge slightly off, then stars wouldn't form, or atoms wouldn't be stable, and life as we know it would be impossible. The universe seems just right.
It does seem exquisitely tuned for complexity.
So how does this hyperharmonics idea explain that apparent fine-tuning? Does it just happen by chance that the harmonics are right for life in our bubble?
No, the framework introduces a specific mechanism to address this. It's called the anthropic operator, usually denoted $1.
An anthropic operator, what does that do?
It's described as a functional, which is like a function that takes another function as its input. In this case, the anthropic operator $1 acts on the coherence function, phase stay.
Okay, it operates on the coherence field. Why?
Its purpose, as defined in the sources, is to essentially guide or constrain the emergence of the hyperharmonics, the constants like G, alpha, etc., to ensure that they align with the specific conditions necessary for complexity, stability, and ultimately life to arise.
Wait, it ensures the constants are life-friendly. How?
It acts like a kind of self-correction or optimization principle embedded directly within the dynamics of coherence itself. It's not an external tuner, but an inherent mathematical property of how coherence evolves and stabilizes.
So, the universe isn't just incredibly lucky to have the right numbers for G and alpha. The underlying coherence field is mathematically structured, via this operator A, to naturally produce life-friendly constants whenever it settles into a stable state.
That's the proposal. It aims to shift the explanation for fine-tuning away from sheer chance or multiverse arguments towards an inherent structural property of the omniverse's physics. It suggests the potential for life is sort of written into the code of coherence dynamics.
That's a very different perspective.
Yeah.
It implies that wherever a stable, coherent emergence event occurs within this larger omniverse, the local physics that crystallizes out the resulting values of G, alpha, H bar will automatically be suitable for complex systems to develop.
Yes, it suggests a universe inherently biased towards complexity and order, driven by these underlying principles.
Okay, that's a profound idea. And it scales up hugely when we get to section 4.2. The concept of the omniverse and what are called multiversal births.
Mm-hmm.
If our constants are just local hyperharmonics, how big is our local environment? And what else is out there?
Right. The framework suggests that what we call our observable universe isn't a single, unique event like the standard Big Bang model assumes. Instead, it's viewed as potentially just one part of a vast network of multiversal births. These are described as distinct, localized, coherent emergence events.
Coherent emergence events, like bubbles of stable reality forming.
Exactly. Bubbles or domains where coherence reaches a level sufficient to stabilize matter and physical laws, the hyperharmonics. And crucially, these events are seen as arising dynamically and perhaps continuously, constantly being generated or precipitating out of the background invariant hypergravity field.
So not just one beginning, but potentially many beginnings happening all the time.
That's the picture. A much more dynamic, ongoing creation process within an eternal omniverse.
The scale of this must be immense. Do the sources give any estimate of how many such events might be within our observational reach?
They do offer a speculative estimate. Based on the scale of the largest observed structures and voids, they hypothesize that what we currently observe in our deep sky surveys, our cosmic horizon, might actually contain evidence of roughly 2.3 million such distinct emergence events.
2.3 million within our observable patch.
That's the number floated, yes. It implies we are truly living within a vast omniverse, a grand tapestry woven from these interconnected, coherent bubbles.
It really reframes how we look at the largest structures in the universe.
It absolutely does. This framework suggests that structures like the Laniakea supercluster, which is our own cosmic neighborhood containing the Milky Way,
Yeah, huge structure.
or even larger structures like the recently discovered South Pole Wall. These aren't just random clumps of galaxies. They are hypothesized to represent either unique, truly massive local emergence events themselves,
Or perhaps the boundaries.
or potentially the structural boundaries or interfaces between multiple overlapping local universes or emergence events.
Wow. Okay, so that gives a whole new meaning to cosmic structure. If the universe is this mosaic of emergence bubbles, then the filaments and walls where we see galaxies clustered.
They would represent the regions of overlap, the high coherence interfaces between these neighboring events. That's where the conditions are most stable and constructive interference happens.
And conversely, the great voids, those enormous, almost empty regions in space.
They would represent the gaps, the regions of low coherence between the major emergence events, places where stable matter formation was less efficient.
So the large-scale structure of the universe isn't just a map of where gravity has pulled matter together over time.
In this view, it's fundamentally a map of the underlying resonant coherence patterns across the omniverse. The largest structures are the physical fossil evidence, if you will, of the geometry of these multiversal intersections and emergence events.
It's a completely different way to read the cosmic map. Okay, finally, section 4.3 touches on the major philosophical and theoretical disruptions this model causes, especially, it seems, challenging the standard Big Bang theory.
Yes, it presents a significant alternative to the Big Bang paradigm.
How so? What's the core challenge?
Well, the standard Big Bang model relies on an initial singularity, a point of infinite density and temperature, which is mathematically problematic. And it famously raises the unanswerable question of what came before the Big Bang.
The before problem, right?
This framework aims to bypass those problems entirely. It offers a process-oriented model, not an event-oriented one. Meaning the universe, or rather, universes emerge dynamically from localized, coherent events occurring within an infinite and eternal hypergravity field. There's no need for a single starting point, no initial singularity. Structure formation and the creation of matter are viewed as continuous, ongoing processes.
That replaces the idea of a beginning with the idea of constant emergence.
Exactly. Emergence within an already existing infinite substrate. It removes the need to explain the absolute beginning or the nothing that preceded it.
That's a huge philosophical shift.
Yeah.
And the sources also include some interesting, maybe more speculative points about light interactions and redshift.
Yes, this touches on how we interpret cosmological observations.
It seems to complicate the standard interpretation of cosmic redshift, which is usually taken as direct evidence for the expansion of space.
It does add a potential layer of complexity. Standard cosmology attributes virtually all observed cosmological redshift to the Doppler effect caused by the expansion of space itself. Galaxies moving away from us stretch the light's wavelength.
Right, the expanding universe explanation.
This framework, however, suggests that some component of the observed redshift might not be due to expansion alone. It proposes that redshift could also occur as a frequency downshift when light interacts with, and potentially loses energy to, vast cosmic clouds of mass, or even just the low coherence medium of space itself over immense distances.
So, like a tired light component, but linked to coherence. Light losing energy as it travels through less organized space.
Something along those lines, yes. Essentially, light interacting with the medium it traverses, causing an energy loss that manifests as a redshift, independent of relative motion.
That's fascinating because, if true, it would mean that some fraction of the redshift we measure, which we currently attribute entirely to expansion,
Might actually be due to this energy depletion effect, which could mean our current calculations of the expansion rate or the distances to very remote objects might need refinement.
it adds another variable to the equation.
It does. And conversely, the sources also speculate briefly about blue shift, which is much rarer cosmologically.
Light shifted to shorter, bluer wavelengths, usually meaning something is moving towards us.
Right. They speculate that some blue shift events might be caused by light gaining energy, perhaps through refraction or specific gravitational lensing effects as it passes through extremely dense, high coherence regions.
So interacting with highly organized matter or space could potentially boost the light's frequency.
That's the tentative suggestion. Now, this doesn't necessarily invalidate the expansion model altogether, but it argues that our interpretation of cosmological light signals needs to be more nuanced. We need to consider the possibility that light's journey isn't just geometric travel through empty space, but an interactive, resonant process within the dynamic hypergravity field and its varying coherence levels.
So our current measurements of cosmic expansion might be slightly skewed or at least incomplete because we're not accounting for these potential coherence-based interactions affecting the light along its path.
It demands a potentially more complex cosmological model, one where the medium light travels through isn't passive. Hashtag outro. So, to trick and wrap up this incredibly deep dive, we've explored a theoretical framework that attempts a grand unification by inextricably linking cohesion, coherence, and resonance. It offers a fundamentally process-driven view of reality.
Yeah, process-driven seems key.
The underlying mechanism proposed is universal resonance, all operating within this backdrop of an invariant hypergravity field. And the implication is that things we consider fundamental mass, stability, the structure of matter, even the physical constants that define our universe are actually emergent properties. They arise naturally from the interplay of resonance and coherence, rather than being arbitrary, fixed rules.
And the implications are just vast. Concepts like hypergravity and coherence suggest that what we call our universe isn't the whole story. It might just be one highly coherent bubble, maybe Laniakea, maybe something even bigger like the South Pole wall structures represent nestled within a truly vast, interconnected omniverse.
A mosaic, perhaps, of millions of these coherent emergence events, all stabilized and governed by the same underlying physics of resonance within hypergravity.
Which leaves us, as always, with a final, really provocative thought for you to mull over. If the gravitational constant, g, isn't actually a fixed, immutable universal law, but rather an emergent hyperharmonic derived from the specific level of coherence in our local patch of the hypergravity field.
Right.
And if that field, through something like the anthropic operator, is constantly dynamically trying to optimize conditions for complexity in life.
Okay.
But what does that imply for the forces holding us, holding you, and holding everything around you together right this very second? Could our own physical existence, the stability of the atoms in our bodies, be a direct function of an ongoing optimized resonant state? A state that, if it were to somehow falter or lose coherence, could fundamentally alter the very stability of matter itself.